This is Ed Robinson of Kensington College, continuing our lessons on C++. We'll be talking today about inheritance. What is inheritance? Inheritance allows us to make a class that's a separate class based upon another class which has all the features of the original class and more. So let's say that we've got a very simple class called arith, which has got an add function in it. It's the simplest we can think of for the moment. Now, if I want to make a derived class, this is how I do it. Public class, and using the colon, and then saying this class is derived from arith. This being the derived class, and this being the base class. And within that derived class, you might want to place extra functionality. For example, you might want to make a subtraction program, since we've already got an addition program. And then you might as well say, well, what's the point of that? I could have just put that in the other class in the first place. Like that. Well, what is the point? Let me just put it back again. The point is that this class here might be in a compiled form, and we don't have direct access to it. At least we don't have direct access to this source code, so we can't modify the class itself. This might be in a library. It might be in an executable form. So that's what I'll do. I'm going to make my class arith a library class. So I'll get rid of all of this in anticipation of just making this code here into a library. So if I wanted to start again, I could just make a library by going through and class library and so on, which we have done previously, and then put this code in and then build the library. Then I would make a console application and add that to the solution. So I'd have two projects, and in this console application I would put some code to run my library code. So in summary, you can see on here that I've got solution, which I've called test arith library, and I've made a library in there which is called libarith, and I've also made a console application to run it, and within that I've got a program file to run it, which we can see here, which should run the code which is in the library. So just in summary, I've got this code which will run the library, and the actual library itself, which is this. We need to obviously set a reference from the console application, which we can do by adding a reference, as you've seen before. Add a reference to the library, and then also we could make sure that this program, this one here, is the startup project. So there's nothing really new here. All we're doing is running the code which is in the library, and it should simply add together the two numbers. I think it'd be instructive to look at the library DLL. I'm going to show all files, which you can see here, and look amongst the binaries, and there it is there. It's a DLL, dynamic linked library. That's where our library code is. You recall, this is our library code, which will be in this file here in the compiled form. So what I'll actually do is go and take a look at this file in binary form. And the way to do that is to go to File and then open our file. But I'm going to navigate to the DLL, which is here, and then I'm going to open with, a binary editor. And there it is. There's the code. Now, it doesn't mean much, does it? It's all in hexadecimal, 4D, 5A, 90, etc., 03. It's all in hexadecimal. So 4D, for example, would stand for 4 16s is 64, plus 13 is 77 in decimal. But that's beside the point. You'll see it's all really, at the end of the day, it's zeros and ones. This is a hexadecimal representation of 0 1s, so it's an executable library file, a DLL, which doesn't mean much to anybody as we look at it now. But you can see if you wanted to modify the class, you'd be in a bit of trouble here trying to individually change these executable bytes. So we imagine that this is our library code, but indeed it's inaccessible. It might have been produced by a third party, for example, but it's inaccessible. But we want to add to its functionality. So we'll take a look at our program class. This is our console application. So we are going to make to utilize that library class. And the first thing I'm going to do is put a using statement in to say that I'm using the library, which is the namespace, which is that. So as well as setting a reference, I need to do that, of course, when I'm running. Now I want to add functionality to the original library. In order to do that, I'm going to put in a derived class. And there it is, my new class, which is derived from, you'll notice this, it's derived from the original class which is in the library. Now how am I going to utilize this? I want to use the subtract function. So if I copy that down, and this time I'm going to use the derived class. And now you'll notice when I press the full stop here, you can see that I've got the subtract function here. So I'll use that instead of the add function. And now I want to subtract two numbers so that when I run the program, you can see I've added together the two numbers in the original class, but indeed I've subtracted the two numbers in the derived class. But the beauty of this is really that the derived class, if I change this, instead of calling the ariths add, you'll notice that derived class has also got access to the add function. Well, you don't see it anywhere, do you? It's not here. Well, it is. It's in the library, which you see on the right-hand side over here in a compiled form. But indeed, I guess, in a way we're cheating a bit because we do have access to the library within our total project. But you can just imagine we don't have access to that code. But isn't that interesting? You see, you've got a derived class being produced, which is based on the arithmetic class, arith class, which you see here. But because we've done that, then the derived object, which is A, also has access to the functionality of the original base class. So there you see what inheritance is all about. Inheritance is about producing a new class based upon another class, and that class would be usually tucked away in compiled form in a library. So a derived class will have its new features plus all the original features of the original class as well. Let's talk about the use of constructors within our original class and our derived class, and how we treat data members. So let's start off by introducing a data member into our class, into our original base class, which happens to be in a library, but you may well, for experimental purposes, just put both classes in the same console application for experimental purposes. Then we will introduce a constructor. It's a no parameter constructor. Forgive me, calling them no argument constructors, which is what we call them in C++. So it's a no parameter constructor which simply initializes the internal variable, so to speak, it gives it the value of 1. And also, for demonstration purpose, I'll just get rid of the function inside of my derived class and replace it with some private data in J, and we've got here a constructor which is a no parameter constructor which simply sets the value of J equal to 3. So for the derived class we're going to set the value of its data equal to 3, and for the arithmetic class, this is the base class, we're going to set its private data equal to 1 using no parameter constructors in both cases. So let me see how I can call I can create an object of type of the derived type, and it's going to therefore call the constructor. So let's see how that works. Well, if I put a breakpoint down here and then I F5 to run it to that position, I'll also take a look in the locals window to see what's going on with D1 here. So I can go back to the code, I can press F11 in my console, and then you can see quite clearly it goes up to the no parameter constructor of the derived class, and will set the internal variable, so to speak, the j equal to 3. So I can continue. Now, what's happened? Before it does that, it's gone off to the constructor in the base class. So it's going to do both things, you see. It started off attending to the constructor here, and it's gone off. And let's see, I'll continue F11. You can see it's setting the internal variable, so to speak, I equal to 1. Now, when it finishes in the constructor, I'll press F11, it jumps back to continue where it was rudely interrupted in the derived class's no argument constructor. So now if I continue that, I'll see that j has been set equal to 3, so I'll press F11 and it comes back to here. Now let me look in my locals window up here. At the moment I'm going to press F11 again, and you'll see that D1 has got both variables set. I has got the value of 1 and the underscore I, and j underscore j has got the value of 3. So the point I'm making here is that calling the constructor, the no parameter constructor, upon the derived class will set the data for both classes. It'll set the data I underscore I equal to 1 and underscore j equal to 3 in this case. Let me introduce now a one parameter constructor in both classes. I'll put my one parameter in the base class, where I'm going to set my internal variable equal to the value which is passed, and I'll put a one parameter constructor into my derived class as well. So now I'll make an object to call the no parameter, the one parameter constructor as well, but let me focus on the one parameter, so I'll eliminate that line for the moment, just so we can see clearly the calling of the one parameter constructor, so that if I do an F5 now to run that, it will build and run, and this line hasn't been executed, so I'm now going to press F11 and see what happens. It goes up to the one argument, the one parameter constructor in the derived class, and it's obviously accepted the value of j is 3 from here. But what is going to happen next? Will it continue its business? No, it gets sidetracked. It goes off to the base class, no parameter constructor, and sets the internal variable, if you like, equal to 1. Now it comes back and where it was rudely interrupted and continues on with the derived class one parameter constructor, and it will set the internal variable j equal to the value which is passed, which is 3. So I'll press F11 and it will now jump out of that, and you can see as it comes back, D2 is null at the moment, but if I execute by F11, you can see over here in the locals window, you might just be able to see that underscore I has been given the value of 1, so underscore j has been given the value of 3. So what's the point of all this? The point is that when you call the one parameter, when you initialize you implicitly call the one parameter constructor, it initializes its value, which is passed to j, but it will also call inadvertently the no parameter constructor of the base class as well. So it does two things. So you notice that when we did this, that it called the one parameter constructor of the derived class and not the base class. But what if we wanted to also call the one parameter constructor of, in other words, this one here? We wanted to call this as well. Well, that's easily done by using this notation, where we call the base classes one parameter constructor. So if we once again put our breakpoint down here, and I press F5 to build and run the program down to the breakpoint, and then if I F11, let's see what happens. As expected, it goes up to the one parameter constructor and passes the value of 3. But what happens next? I'll press F11 again. What do you think is going to happen next? Yes, it's going to go to the one parameter constructor of the base class and pass the value of 4. Continues on setting the internal variable to 4 and now returns to the derived class's one parameter constructor and sets the value of 3 and continues on its merry way after that detour. And then now if I take a look now, if I single step and press F11 again and take a look at D2, you'll see that its I has been set to 4 rather than the default value of 1. It's been set to 4, and j of course has been set to 3 as previously. But that's how you call both one parameter constructors, by using this notation. So as an exercise, I suggest you could try your hand at making a two parameter constructor. You'll obviously need two variables inside your class. Well, let's say we had our other internal data type was of underscore k, and we want to call that from here to initialize using a two argument constructor. Well, this is all fairly standard stuff, really. Inheritance or no inheritance. So we need to make a two parameter. And we also need to set our internal variable. So that's standard procedure, but you might like to experiment with trying to call the two parameter constructor of the base class as well. So you'll need to make a two parameter constructor in the base class. Let's return to our simple example where we don't have any derived classes. We're simply calling a function which is in the library, and when I run that, I'll do F5, and that simply produces the result of 3 plus 1. We're now going to make a derived class, and the purpose of the derived class is to produce a function which will override the function in the base class. So this is the method in the base class, and we're going to override it in our derived class. Why would we want to do that? Well, it might be there was someone that made a mistake in making their method. They might have used the wrong sign, just in error, for example, and we want to make amends for that. Well, first of all, the designer of the class has got enough foresight to have called this virtual, which means this can potentially be overridden. So we'll start off by placing our derived class, and we're going to include our own add function, which is going to replace, if you like, the original add function in the base class. So we'll put our function method inside the derived class, which is going to replace that one, but because we are going to replace it, we have to use this keyword override to say that this method is going to override the method add in the base class. So let's test it out. We'll create an object of the derived class, and then we'll call our function calling the add function, so that when we run that, it's 3 plus 1, giving us the 4. So you can see it has indeed called our add function. So if I single step that, I can F5 to run it down to there, and then I can single step F11 to see which function is called. Will it go to the base class? Certainly not. It goes to the derived class and produces the amended result, so giving us the value of 4. But let's see what happens if I don't have an add function, an override function in the derived class. So if I just comment that out and then run the code again with an F5, and it comes to the add function, but where is it going to go to next line? F5, F11 I should say. So now to single step from here, where's it gone? It's gone over here into the base class add function. So it'll return the incorrect result, which is our value of 3. So you can see that C# in a way is quite forgiving, that when it comes across a function, it goes looking up the tree. It can't find one here, and then it continues up the tree onto the base class to use the add function in the base class. Incidentally, if we make the declared type base class and the defined type as derived class, when we run the code, we'll see that we get the add function from the derived class has been called. So even though we've declared a base class type, it's the defined type which determines which method is called in this case.